Good afternoon, everyone. I'm really excited to talk to you today about marine surveillance using radar technology. So, let's just get into it. Importance of marine surveillance. First, let's discuss the importance of marine surveillance, as the oceans are critical for global trade, transportation, and security. Effective surveillance is essential to ensure the safety of all kinds of vessels, to help protect them and people from accidents, prevent illegal activities, and respond to emergencies. With the increase in maritime traffic, robust surveillance systems are more crucial than ever. Role of radar technology in enhancing maritime safety and security. Radar technology plays a pivotal role in enhancing maritime safety and security. By providing real-time detection and tracking of vessels, radar helps prevent collisions, aids in navigation, and supports search and rescue operations. It is particularly effective in all weather conditions, day or night, making it an indispensable tool for marine surveillance. Brief overview of the presentation structure. Today, I will walk you through the principles of radar technology, explaining how radar works and the key components involved. We will then explore its specific applications in marine surveillance, discussing both X-band and S-band radar systems and their respective advantages and challenges. Finally, I will touch on future trends and advancements in radar technology that could further enhance maritime operations. By the end of this presentation, I hope to provide a comprehensive understanding of how radar technology is effective in marine surveillance and why it is so vital for maritime safety and security. What is radar? Now, let's start off with what is radar. Well, the definition of radar stands for radio detection and ranging. It is a technology that uses radio waves to detect and locate objects. Essentially, radar systems send out radio waves and analyze the echoes that return after bouncing off objects in their path. Basic principles and how it works. Transmitter emits radio waves. The process begins with the transmitter, which generates and emits radio waves into the environment. These waves travel through the air in either any direction or a targeted direction. Then the waves reflect off objects and return to the receiver. When these radio waves encounter an object, such as a ship or an aircraft, they bounce back. This reflection is known as an echo. The radar's antenna receives these reflected waves. After, the receiver processes the return signals. The receiver captures these return signals and processes them to extract valuable information. By analyzing the time it takes for the waves to return, and any changes in their frequency or phase, the radar system can determine the distance, speed, and direction of the object. Understanding these basic principles is crucial, as they form the foundation of how radar technology operates. Principles of radar operation. Now that we know the key components of a radar system, let's talk about the principles of radar operation. Pulse transmission. Radar systems typically send out short bursts or pulses of radio waves. This is known as pulse transmission. These pulses travel through the air and help in detecting objects at various distances. By emitting pulses instead of continuous waves, radar can conserve energy and more accurately measure the distance to an object based on the time it takes for the pulse to return. Echo and reflection. When a pulse hits an object, it reflects back to the radar system. This is referred to as an echo. The time it takes for the echo to return to the radar system is used to calculate the distance of the object. The strength and characteristics of the reflected signal can also provide information about the object's size and material. Doppler effect. Another important principle is the Doppler effect. When an object is moving, the frequency of the return signal changes. If the object is moving towards the radar, the frequency increases. If it's moving away, the frequency decreases. This change in frequency can be used to determine the speed and direction of the moving object. The Doppler effect is particularly useful in distinguishing between stationary and moving objects and in measuring their velocity. By understanding these principles, pulse transmission, echo and reflection, and the Doppler effect, we can see how radar systems effectively detect and track objects. These principles form the basis of how radar operates and are crucial for its application in marine surveillance. Marine surveillance applications. Now that we've covered the principles of radar operation, let's explore how radar is applied in marine surveillance. Navigation. First, radar plays a crucial role in navigation. It helps ships navigate safely through crowded or foggy waters where visibility is limited. By providing a clear picture of the surroundings, radar enables vessels to avoid hazards and reach their destination safely. Collision avoidance. Another critical application is collision avoidance. Radar systems can detect and track other vessels in the vicinity, helping to prevent collisions. By monitoring the movement and speed of nearby ships, radar provides early warnings and allows for timely evasive actions to avoid accidents. Search and rescue. Radar is also indispensable in search and rescue operations. It can locate vessels or people in distress, even in harsh weather conditions or low visibility. The ability to quickly detect and pinpoint the location of those in need significantly enhances the effectiveness of rescue missions, potentially saving lives. Environmental monitoring. Lastly, radar is used for environmental monitoring. It tracks weather patterns, waves, and sea ice, providing valuable data for weather forecasting and environmental protection. By monitoring these elements, radar helps in preparing for and mitigating the impact of severe weather conditions on maritime operations. These applications demonstrate the vital role of radar in enhancing maritime safety and efficiency. Whether it's navigating safely, avoiding collisions, rescuing those in distress, or monitoring the environment, radar technology is essential for effective marine surveillance. Types of marine radar systems. Now, let's discuss the types of radar systems commonly used in marine surveillance: X-band and S-band radar. X-band radar. First, we have X-band radar. This type of radar operates at a higher frequency and provides high-resolution images. Due to its shorter wavelength, X-band radar is ideal for detecting smaller objects, such as buoys, small boats, and other vessels in close proximity. Its high resolution makes it particularly useful for navigation in crowded waters and for collision avoidance, providing detailed images that help in identifying and tracking smaller targets. S-band radar. Next, we have S-band radar. This radar operates at a lower frequency compared to X-band and provides lower resolution images. However, its longer wavelength gives it a longer range, making it better suited for detecting larger objects, such as ships, at greater distances. S-band radar is also more effective in adverse weather conditions, as its longer wavelength can penetrate rain, fog, and sea spray more efficiently. This makes it invaluable for long-range surveillance and navigation in poor weather. Understanding the differences between X-band and S-band radar systems helps in selecting the appropriate technology for specific maritime applications. Advantages of radar in marine surveillance. Now, let's explore the key advantages of using radar in marine surveillance. All-weather capability. One of the most significant benefits of radar is its all-weather capability. Unlike optical systems, radar operates effectively in fog, rain, and darkness. This ensures continuous and reliable monitoring of maritime environments, regardless of the weather conditions. Long-range detection. Radar systems are also capable of long-range detection. They can detect objects far beyond the visual range of the human eye or other optical instruments. This extended range is crucial for early detection and response, providing ample time to make informed decisions. Real-time monitoring. Another critical advantage is real-time monitoring. Radar provides continuous updates on the positions and movements of objects. This real-time data is essential for maintaining situational awareness and ensuring the safety and efficiency of maritime operations. High accuracy. Lastly, radar offers high accuracy in measuring distance, speed, and direction. These precise measurements are vital for effective navigation, collision avoidance, and search and rescue operations. The accuracy of radar systems ensures that maritime activities can be conducted safely and efficiently. These advantages highlight why radar is an indispensable tool in marine surveillance. Its ability to operate in all weather conditions, detect objects at long range, provide real-time monitoring, and deliver high accuracy makes it essential for maintaining maritime safety and security. Future trends in marine radar technology. Finally, let's look ahead at some future trends in marine radar technology that promise to further enhance its capabilities. Integration with AI and machine learning. One of the most exciting developments is the integration of radar systems with artificial intelligence, AI, and machine learning. These technologies can significantly enhance target identification and reduce false alarms. By learning from patterns and anomalies in radar data, AI algorithms can improve the accuracy and reliability of radar systems. Improved signal processing. Another important trend is improved signal processing. Advances in this area are leading to better clutter reduction and more precise target tracking. Enhanced signal processing techniques allow radar systems to filter out unwanted noise and focus on relevant targets, improving overall performance and accuracy. Compact and energy-efficient systems. We are also seeing the development of more compact and energy-efficient radar systems. Advances in hardware are making radar systems smaller, lighter, and more versatile, without compromising their capabilities. These improvements make it easier to deploy radar systems in various maritime settings and reduce operational costs. Networked radar systems. Lastly, the future will see more networked radar systems. By sharing data between multiple radar units, these systems can provide comprehensive coverage and a more detailed picture of the maritime environment. Networked radar systems enhance situational awareness and coordination, especially in complex and large-scale operations. These future trends in marine radar technology will continue to enhance maritime safety, efficiency, and security. By integrating AI, improving signal processing, developing compact systems, and networking radar units, we are pushing the boundaries of what radar technology can achieve. To wrap up, radar technology plays a vital role in marine surveillance by providing all-weather capability, long-range detection, real-time monitoring, and high accuracy. Despite challenges like signal clutter, ongoing advancements in AI integration, signal processing, and networked systems promise to further enhance radar's effectiveness. Looking ahead, these innovations will continue to improve maritime safety, efficiency, and environmental monitoring. Radar remains pivotal in navigating, avoiding collisions, conducting search and rescue, and monitoring marine environments. Thank you for your attention. Please let us know how we did in helping you better understand just how marine radar technology is used.